This is okay. Advanced vectors, take one. So what is a vector? First we're going to kind of go through.
You have multiple takes.
Yeah. I'm going to do this after school by myself. So vectors, take one. Actually, I'm going to be gone a couple weeks on Friday, so I might actually do it by myself.
And then have the sub play it for us?
Yeah, and then have the sub play it. What's wrong with that?
Nothing.
That'll work. Okay, so with this one, a vector is a quantity which has both magnitude and direction, usually represented by an arrow. If a vector represents the speed and direction of an object, it is a velocity vector, represents the direction and amount of force. It's a force vector. So when you look at vectors, they just kind of look like lines with arrows on the end. So this might indicate, for instance, that this would be a plane going 800, oh, that's pretty fast for a plane, 800 miles an hour if you'd be breaking the sound barrier.
It's out of direction because it's a vector.
What? Yeah, it's got that, and it's going in that direction. But if I had another plane, like going this way, so this might represent a plane going south at maybe 100 miles an hour or something like that, right? And you have to add and subtract vectors and things like that. And so the length of the vector indicates how fast or how much force is acting on it, and the direction indicates what direction it's going. Okay? I'll talk more about this as we go through. But a directed line segment, you have a starting point P1 and an end point P2. The magnitude is the distance from point 1 to point 2. So if this is point 1 over here, and this is point 2, okay, this would be vector P1, P2. This is the initial point. That's the terminal, which also means end point. And the magnitude is the distance from here to here. A zero vector is a vector that has no magnitude or direction. A unit vector is a vector with a magnitude of 1, but in the same direction as the original vector. So if I had another little vector, let's make like a little blue vector kind of going this way. Like a little vector going up like this, okay? And it was going, say, in this case, 1 mile an hour. That's not really the scale. And it was going in the same direction as this one. That's called a unit vector, okay? And it has a magnitude of 1. The standard, a unit vector, but it has the same direction. The unit vector in the horizontal direction is I, and the vertical direction is J. We'll talk about that in a second. Standard position of a vector, initial point is the origin 0, 0. But they don't always have to start at 0, 0. Component form of a vector has an initial point A, B1, and an end point A, B2. And to find the components of the vector, you subtract A2 minus A1 and B2 minus B1 to find this is like the X part, and this is like the Y part. Sometimes they call this, it's A in the I direction, they write it like this, and plus B in the J direction, like that. So this, and they put little hats on them. In our book, they don't do that, okay? So A hat, B hat, okay, and that indicates that that's a vector. But in our book, I don't think they put the little hats on it, but I know they do in the physics book. Magnitude of a vector is just like we've been finding magnitude. It's the length of the vector. Also, if you take the square root of this plus the square root of that, or the square of that and the square of that, and you take the square root, you'll get the magnitude. Equivalent vectors have the same magnitude and direction, so they would be going, like if I put another vector up here, and it's also going this way, and it was 800 miles an hour, like like fighter jets, you know, you see them flying through the skies in pairs of twos, right? They would have to be equivalent vectors, otherwise they'd crash into each other, right? You see like when they do those acrobatics and stuff, you know, they'd be flying same speed, same direction, usually, okay? Scalar product is a vector in which each component is multiplied by a scalar or a number, okay, affecting the magnitude but not the direction. For instance, if I took 3 times some vector 5, comma 7, okay, so this represents a vector 5, comma 7, it would just be 15, comma 21. Still be going in the same direction, but it would be 3 times as 1, and we'll do one of those. And now we have some example problems. Who do you? Yay. Okay. So, scalar product, a vector in which each component is multiplied, but we talked about it. Find the position vector P1, P2, if P1 is -1, 2, then P2 is 4, 6, and graph both the original vector and the position vector. So to graph the original vector, I am going to try to draw a better XY axis on here because it's kind of hard to see. Is that a better XY axis? Oh, not so much. Going across like this. Let's move this guy. I can do that. I can nudge him. Is that better? Not really. It's good. Anyway, so so if I start at -1, 2, which is, as you know, is here, okay, and 4, 6, 1, 2, 3, 4, up 6. Here is the vector P1, P2, which goes from, we'll do it in different color, which goes from here to there, okay? So that's the original vector, okay? To find the position vector, that's a vector that has same magnitude and position but is down here. So in order to do that algebraically, all I do is I subtract the x's. It's just like you're finding slope except backwards. So I go 4, so that would be 4 minus -1, comma 6 minus 2. Okay, I subtracted the x components. This is the end point of the x from the start point of the x, and I subtracted the start point of the y from the end point of the y, and I get this vector which is 5, comma 4. So in other words, if I started here at 0, 0, and I went over 1, 2, 3, 4, 5, and up 1, 2, 3, 4, I should get a vector that is equivalent to that vector, but starts at the origin. Get it? Get it? So this is a position vector, and this is the original vector, and they're equivalent. They're just not, they don't originate from the same place. And how do you add and subtract vectors? You add and subtract their x's and their y's. So this is saying like, uh-oh. Uh-oh. I'm running out of juice here. That's a problem. The pen, I can't continue. The pen is running out of juice. I can't, because then I can't post my notes. I was doing so well, too. Plug it in. Okay. That's a good idea. So, oh, I can't put it in because
They gave me purple.
maybe.
But it was good.
You asked for blue or green.
I remember.
They were like, purple. I guess you make cool colors.
It's okay, because I didn't have to pay for it, and it was still free. So, totally.
So,
This is my favorite part. Right here. Especially the forks.
so now let's see if this works. I have to sit down and do this. Read the properties of vectors on page 609, commutative, associative, additive, etc. You can read about those. Okay? So what that means is that commutative means that you could add vectors, vector A plus vector B, or you could add vector B plus vector A, and you'll get the same thing. That's what commutative means. Associative means if you have three vectors, like A or vector B plus W plus, let me write that. If I have like three vectors, like V plus W, so say that each one of these represents a vector, V plus W plus, I don't know, Y, something like that. I can either put parentheses here, add those two and add Y to it, or I can take V and add them like this, W plus Y. That's what associative means, okay? Additive identity means you can add 0 to it and it won't change the vector, okay? Additive inverse means you could add the opposite and end up with 0. So 0 vector V plus negative V will give you the 0 vector, okay? And that's what that means. That's all that is. And this says if I multiply a vector by a number, I multiply its components, and we'll get to that in a second. Okay, next. Oh, I'm talking, so I'm going to face this towards me. One minute. So next, we're on the next page, right? So how do I do this stuff? So if I were going to add vector U plus vector V, find each specified writing component form graph and find its magnitude. So U plus V is just going to be, 3 plus negative 3, 3 plus negative 3, comma, 3 plus 1, which gives you what? 0, comma, 4. Or the other way I could write that is just 0 in the x, 0I plus 4j. I is the x direction, j is the y direction, okay, when you're talking about vector. And so what that means, if I took this vector starting at 0, 0, and I went 1, 2, 3, up 1, 2, 3, and I made a little vector right there. Whoops, I wanted u plus v, not v plus u. Sorry. So I'm going to start with u. So I'm going to go back 3, 1, 1, 2, 3, and up 1, and put a point there, and graph that vector. Whoops, it's yellow. It's okay. Can't really see that, can you? Can you see that? We'll make it a different color. Why is it still yellow? Who cares? Okay. So there's that vector. And then if I add to that the vector v, which is up 3 and over 3. And when you add vectors, you go from the tail of one to the start. You start the second vector that you're adding at the end of the first vector. So now I'm going to add vector v to it. So that means from that point I go over 3 and up 3, okay, which would put you right there from this point. And I'm going to sketch in that vector. Okay. I'm going to go like that. Okay. And my resultant vector is this vector right here, okay, that goes from there to there. Which, as you see, so if I add these two yellow vectors, I get that red vector. And notice that that is the same as going over 0 and up 4, right? Or 0 plus 4i is another way of saying that same thing. Get it? Yes, sir.
How do you know if the vector starts at the origin?
If it's just like this, then start it at the origin, okay? And I could have started this one at the origin and then added this one to it, and since it's commutative, I would have ended up at the same place. See? I could have gone over 3 and up 3 and then back 3 and up 1, and I would have got to that same point, and I still would have got that red vector as the answer.
Wait, so you started?
I started right here,
Okay.
and I went vector u plus vector v, and I got vector,
Yeah, but you went up 3 and over 3 from...
no, for the first one, this says u plus v, right? So I went back 3 and up 1.
Yeah,
And then from this point,
yeah, okay.
I went over 3 and up 3. Okay? All right. So if I wanted to do this, 2u minus v, so I would have got, to do that algebraically, let's do it using i's and j's. So u would be negative 3 I plus j, and v would be, v is 3i plus 3j. And so if I wanted to go 2 of these minus 1 of those, okay, my I components are negative 6 minus 3 in the I direction. Do you guys see where I got that from? 2 times negative 3 minus 3. Altogether, you count up all your I's. So that's how many I's I have. And then my J's are, how many J's do I have altogether? 2 minus 3. Do you guys see that? 2 times 1 minus 3. And so in the j direction, so altogether I get minus 9i minus j. Okay? Or you could write that equivalently as minus 9 comma minus 1. In other words, if I took 2 of these u vectors, which go back 3 and up 1, so let's just show you that. So if I took 2 of these u vectors, I'd go back 3 and up 1, and then back 3 and up 1 again. Whoops, from that point, I do the same thing again. There's 2 of my u vectors, even though it's not really good how I drew it. And then I take away a v, so I do the opposite of v. So instead of going over 3 and up 3, I go down 3 and back 3. So from this point, I went down 3 and back 3. I'd end up like minus,
You do the opposite.
I'm doing the opposite. I messed up. So from this point to my 2u, that's right, minus v, so I go back 3, oh, I'm sorry, back 3 and down 3, I would have been right at this point, which would put my resultant right here at this would have been my resultant vector, which is back 9 and down 1. Do you see that? Yes? No?
Yes.
Good. All right. And then you can figure out how to do this one. This one, to find a unit vector, I just divide that vector by its magnitude. So if I have vector v, good, I'm going to make it a little bigger here. So vector u, which is negative 3, 1. Is that v? Yeah, that's a u. So u equals negative 3, 1. So to find the unit vector, I take that vector, which is negative 3 in the I direction, plus 1 in the j direction, and I divide that by its magnitude, which is square root of negative 3 squared, plus 1 squared, which is equal to negative 3 plus j over the square root of 9 plus 1 square root of 10, which is equal to, whoops, that's I, which is negative 3i over root of 10 plus j over root of 10. And what that means, that's, if I were to graph this unit vector, if this is my original vector, which goes back 3 and up 1, like this, then this unit vector, I'd go back negative 3 over root of 10 and up 1 over root of 10, and I would get a vector in the same direction as that vector, except it would only have a length of 1. So that little tiny purple thing right there, that would be the unit vector. Yes? You understand? ¿Entiendo? No? Did I say that right in Spanish? And how? ¿Entiendes? ¿Comprendo? Me gusta? Never mind. Okay? Next, last thing we're going to talk about here. We're not going to get to this last one, or we're going to get to this, but I went for the wrong, I didn't do this example. That's okay, I did a different example. That's all right. So, so the last thing is, so a ball is thrown initial speed of 25 miles an hour. This is where vectors come in handy with projectile motion and stuff. So say, for instance, that here's the ground, okay? And you throw a ball, you like playing baseball, right? Ryan, right? You like playing baseball too? Okay. So, Austin likes playing baseball too. So this would be 25, the ball is thrown at 25 miles an hour, okay? And this angle at which you throw it is 30, uh-oh. What's going on? Uh-oh, it's got the shakes. This is 30 degrees right here. And what this equation right here does is it lets you break this up into two components, okay? One which is the x direction, or the I direction, and one which is the j direction. So if I throw this ball at 25 miles an hour this way, what this is asking me is how fast is it going this way, and how fast is it going this way, okay? And the way you do that is just using this formula, or you could use trig a little bit, but if this angle is 40 degrees, the magnitude in this case is still 25. So it's going to be 25 cosine of it's 25 cosine alpha is the angle, okay, of 30 in the I direction plus 25 sine of the angle, sine of 30 in the j direction. And since we all remember our unit circle, it's 25. Anyone remember what the cosine of 30 is? Root of 3 over 2. Very good, Parker. Root of 3 over 2. Oh, that very good, Kyle. Plus 25 times 1/2 in the j direction. Or this is about 12.5 root 3 in the I direction plus 12.5 in the j direction. In other words, if I throw this ball at 25 miles an hour this way, it's going 12.5 root 3 this way, which is about 20 point something miles an hour, and it's going about 12, what? 21.65. So it's going about 21.65 in this direction, and at the same time, it's going 12.5 miles an hour in this direction. Okay? So even though it's going 25 that way, okay? So that's how you do that. So for your homework, we'll skip 61 and 65 for tonight. So all you really have to do is these ones. All right? I mean 61 and 66. The end.
So physics is the